Hello and welcome to another GCSE revision video, and in this video we're going to be looking at accuracy. I think this is arguably the most overlooked and ignored section on the entire GCSE syllabus. For some reason people don't seem to know why they should bother with the degree of accuracy of their answers. So I'm just taking a few seconds here to try to explain why this is important. Accuracy is about being honest about how much you can trust your measurements. Have you ever found that two components don't fit together the way they should? Like if you got a couple of Lego blocks and they don't quite fit together well, you have to squeeze them together hard, or when you come to try and take them apart, you have to use a lot of force to get them apart. That's because when they were manufactured, one or both of the components were not manufactured to the appropriate degree of accuracy. An awful lot of mechanical failures occur because people don't pay enough attention to how accurate they've given their answers to their calculations. When it comes to counting decimal places, all we do is count the number of digits after the decimal point. So 2.5 is accurate to one decimal place. 3.47 is accurate to two decimal places. And 0.009 is accurate to three decimal places. When it comes to significant figures, if the number is bigger than -1 and smaller than 1, then start counting from the first non-zero on the left-hand side. So 0.5 has one significant figure, 0.25 has two significant figures, 0.123 has three significant figures, so does -0.123, and so does 0.000123. In fact, it doesn't matter how many leading zeros you have after the decimal point, you start counting from the first non-zero. However, after the first non-zero, all zeros do count as significant figures. So 0.100000 has five significant figures. Well, if I counted the zeros correctly, there's 1, 2, 3, 4 zeros after the 1, so there's five significant figures. Zeros that are not significant are just placeholding zeros. They're there to make sure all the other numbers have the correct value. If the number is smaller than -1 and bigger than 1, then start counting from the beginning until you come to the last non-zero on the right-hand side, unless the number has a decimal point. So 120,000 has two significant figures. 120,100 has four significant figures. 120,100.05 has eight significant figures. Zeros that are in between non-zeros are counted as significant. Remember, all digits from 1 to 9 are significant. Zeros in between non-zeros are significant. If a non-zero is both left and right of a decimal point, then all digits are significant. Okay, well, so much for the theory. Let's have a go at putting this into practice. Give the level of accuracy of the number 0.34. Okay, well, we have a 0, so this is between -1 and 1. And then after the decimal point, we have 1, 2 digits that are both non-zero. So this is accurate to two significant figures. If we want to give the accuracy to decimal places, we've got our decimal point here, and there's 1, 2 values after the decimal point. So this is also accurate to 2 decimal places. So how accurate is the number 64.025? Well, what we have here is a number that's bigger than 1. So we start counting from the leftmost side. It has a decimal point, so all the digits are significant digits. So we've got 1, 2, 3, 4, 5. So this is accurate to 5 significant figures. Now, after the decimal point, we have 1, 2, 3 digits. So this is accurate to 3 decimal places. Okay, let's just try one more example. Let's pick something like 0.00510. Okay, so what we have here is 1, 2, 3, 4, 5 decimal places. And we're not counting any zeros to the left of the first non-zero after the decimal point. So these leading zeros do not count. So we've got 1, 2, 3 significant figures. This 0 does count because you don't need to put it in at all if it's not significant. So this is a significant 0. So this number has 3 significant figures. Okay, why don't you have a go at making up some numbers yourself and counting the number of decimal places and significant figures. I'd like to wish you all the best with your revision and all the best with your exams, and I'll see you in a future video.